Building on that idea, enforcement begins with the principle of default deny and explicit allow. In practice, this means access is blocked by default unless a rule specifically grants permission. This default posture reduces exposure from configuration errors or forgotten updates. For example, when a new application module is deployed, users cannot interact with it until roles or attributes explicitly authorize them. Default deny may feel restrictive at first, but it creates a predictable security baseline. It forces clarity about intent. What is truly necessary becomes permitted, and everything else stays sealed. Explicit allow is the digital equivalent of a locked door opened only by key, not by convenience. From that foundation, mapping subjects, objects, and permitted actions turns the abstract principle into a working model. The subject is the actor, the object is the resource, and the action defines what can be done. Together, these relationships form the access control matrix. For example, a payroll clerk may read and update employee records but cannot delete them. A well-documented map allows easy verification of who can perform which operation and why. Without it, organizations risk tangled policies that overlap or contradict. Mapping makes enforcement traceable. Every permission can be traced to a justified purpose and a designated owner. Centralizing decisions while distributing enforcement points strikes a balance between control and scalability. A centralized policy engine ensures consistent logic, while distributed enforcement points, such as application gateways, APIs, or microservices, execute those decisions locally. This pattern allows updates to propagate everywhere without rewriting code in each system. For example, changing a rule in the central policy server immediately affects all connected applications. However, enforcement points must validate signatures and timestamps to ensure decisions remain trustworthy. This architecture prevents drift between intent and execution. Centralized decision-making with distributed enforcement keeps governance uniform while allowing performance and resilience in diverse environments. Modern systems combine role-based and attribute-based policies to fine-tune access decisions. Role-based control defines what members of a group can do, while attribute-based control adds context, such as project, department, or clearance level. The combination provides both structure and flexibility. For instance, a developer role may allow code repository access, but only if the user's attribute project matches the repository tag. Blending these models avoids rigid hierarchies without losing clarity. The trick is maintaining policy readability. Complex combinations quickly become opaque. A mature enforcement system favors simplicity that humans can review and machines can evaluate quickly. Context signals like time of day, device type, or location further refine enforcement. These signals introduce adaptive decisions, allowing access when conditions are safe and restricting it when risk increases. Imagine a user who can approve payments during business hours from a corporate network, but must perform additional verification when traveling abroad. Context-aware enforcement prevents over-permissioning while preserving usability. Collecting and validating these signals requires coordination with identity providers and endpoint management systems. The outcome is dynamic trust, where permission adjusts automatically to changing risk, turning enforcement from static defense into intelligent response. Before any policy is evaluated, the system must validate the incoming request itself. That means confirming the request is properly formatted, authenticated, and free of injection or tampering. Policy evaluation is only meaningful if the input is reliable. For example, a malformed API request pretending to come from an authorized user should be rejected before reaching the enforcement logic. Early validation prevents exploitation of parsing errors or unexpected parameter values. It also protects policy engines from being overloaded with invalid data. Secure request validation acts as the gatekeeper that shields the decision engine from corruption or abuse. When policy evaluation encounters errors, the system must fail securely rather than fail open. Failing open means granting access when rules cannot be processed, a catastrophic design flaw. Failing securely means denying access until certainty is restored. Suppose a policy database becomes temporarily unavailable. The system should default to block rather than permit requests. Error handling should also generate alerts for administrators to investigate. Secure failure ensures that uncertainty never becomes an entry point. In access enforcement, silence or confusion must always resolve to no. That discipline separates resilience from risk. Propagating identity and claims reliably across systems ensures decisions remain accurate. Each access request depends on identity attributes, such as role, clearance, or authentication level, passed from identity providers to enforcement points. If these claims are tampered with, outdated, or unsigned, decisions can become invalid. Using strong token formats, digital signatures, and expiration timestamps helps preserve trust. For example, in a federated environment, a signed identity token proves authenticity across cloud and on-premise systems. Proper propagation ensures that enforcement points see the same truth about the user, maintaining consistency across every boundary where access decisions are made. Logging access decisions with rationale and identifiers provides transparency and accountability. Each log should record who requested access, to what resource, whether the request was allowed or denied, and why. This evidence supports both operational review and forensic investigation. For instance, seeing repeated denials from a specific source may reveal a misconfiguration or intrusion attempt. Logging is not only about recording success and failure, it's about explaining outcomes in a traceable way. When decisions are logged with reasons, trust extends beyond enforcement to auditability. The log becomes both a shield and a mirror, protecting systems and reflecting discipline. Handling denials with user-safe messages prevents confusion and security leaks. Error responses should inform users that access is denied without revealing sensitive details about system configuration or policy logic. For example, rather than stating access denied, missing admin role, the system might say access denied, authorization required. Clear yet minimal feedback maintains usability while avoiding clues that attackers could exploit. Well-crafted denial messages also reduce frustration and support help desk triage by guiding legitimate users toward the proper escalation path. Secure denial is not hostility, it is communication with discretion. When exceptions arise, they must be time-bound and supported by compensating controls. Temporary access for troubleshooting or emergencies should include defined expiry, documented approval, and extra monitoring. For instance, an administrator granted elevated rights to fix a production issue should lose those rights automatically after completion. Tracking these exceptions prevents privilege creep and reinforces fairness. Compensating controls, like logging every action or requiring secondary approval, balance flexibility with accountability. Exceptions handled informally erode the system's credibility. Handled formally, they showcase disciplined trust management. Temporary elevation should always come with a timer and a trail. Evidence of access enforcement must include rule sets, approval records, and sampling exports that show decisions working as intended. Policy files, configuration backups, and audit logs form the documentation auditors rely on. Periodic sampling, testing whether real-world results match policy definitions, demonstrates operational integrity. For example, running automated scripts to verify that all high-risk systems enforce multi-factor authentication proves that enforcement aligns with design. Evidence should be retrievable and version-controlled, showing who changed what and when. Together, these records turn abstract authorization principles into a verifiable compliance story that stands up under examination. In the end, consistent and testable access enforcement transforms security intent into daily assurance. AC-3 reminds us that permission is a living contract between user and system, renewed each time an action is attempted. When default deny, validated inputs, and secure failures become habit, breaches lose their easy paths. Enforcement done right requires precision, not complexity, rules that are clear, decisions that are logged, and errors that fail safely. With these disciplines in place, access control evolves from reactive policy to active defense, ensuring that what should be protected always stays protected, by design and by proof. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.